Hi everyone, my name is Lydia and this is what I wish they taught me about econometrics and introduction. In the previous video, we interpreted the level model, and this is how we wrote it. In this video, we're going to start with another model by changing just one thing, and that will be taking the log of the y. That might look as if we're not changing much, but will completely change how we interpret the coefficient. So the second model we're going to look into is the log level model. We're going to take the log, or we're going to write most of the time ln of y, so the logarithmic with base e equals to beta 0 plus beta 1x plus epsilon. Notice that we did nothing to x. The only changes we applied are to the y. Okay, so keep in mind, the y only is in logs. This is also called a semi-log model, or in some books, you might see it as semi-elasticity model. Now, what changes conceptually between these two models? So in the level model, we had beta 1 measuring unit changes in y, but now the beta one that we have is going to measure changes in log y. So now, changes in log y, or ln y, as we've written it. Now, log y or ln y does not have a direct economic meaning. This is why we need to understand what needs to be done. There is a very key idea that is used here throughout. We're not going to dive too deep into that in this video, but this key idea that you have to remember is that there is an important approximation. So logs turn changes into percentages. Okay? And the important approximation that we're kind of looking into here is that the changes in ln y are approximately changes in y divided by y. Okay, so a small change in log y is approximately the percentage change in y. And this is that bridge, this is that key idea that you need when you step into the interpretation of the coefficients for the second model that we have in here. So let me rewrite the model once again. ln y equals to beta 0 plus beta 1x. And let's say this is the estimated one, so let me put hats everywhere in here. Let's say this is what we have estimated. So this beta 1 hat in here will tell us the approximate percentage change in y associated on average with a 1 unit. So look here, this is not changing. A 1 unit increase in x. Okay, so if for whatever reason, let's say we've got a beta 1 hat here that is 0.05, we're going to say that a 1 unit increase in x increases y by approximately 5%. Okay, so keep in mind, not 5 units, not 0.05 units, but 5%. Now, this interpretation is exact for small changes. For larger coefficients, you have to use a more precise formula, and we'll see both cases together and also the derivation of the math for them. So the only key takeaway out of this video is that we have now a new model. we're using the idea that logs turn changes into percentages. So now from a 1 unit change in X to a unit change in Y, we're looking to a unit change in X into a percentage change in Y. And this is the key shift. So in a log level model, the slope coefficient tells you the approximate percentage change in Y for a 1 unit increase in X. In the next video, we'll prove everything formally, so stay tuned and I'll see you then.